Welcome to Study Loop.
So in this problem, we are given with a reaction of the formation of sulfur trioxide from the reaction of sulfur dioxide and oxygen gas. So here we are given the equilibrium constant in terms of pressure for this reaction as this, and we are given the temperature at which the reaction is taking place, which is 700 Kelvin, and we are given the mass of the product sulfur trioxide and mass of the oxygen. These are the masses in the at the equilibrium, and we have to find out the equilibrium mass of sulfur dioxide. So what we have to do for this is, first we have to convert this these masses into number of moles of sulfur trioxide and oxygen, and from there using the volume of the solution, which is also given as 2 liter. So using the number of moles and the volume, we can find out the equilibrium concentration of sulfur trioxide and oxygen. And then we have to find out the equilibrium concentration in terms of molarity using the equilibrium concentration in terms of pressure. And then we will have to set up an equilibrium constant expression for the Kc value, from where we will be able to find out the equilibrium concentration of sulfur dioxide, just using the equilibrium concentration of sulfur trioxide and oxygen. And then from the equilibrium concentration of sulfur dioxide, we will be able to find out the number of moles of sulfur dioxide, and from there we will be able to find out the equilibrium mass of sulfur dioxide. So the first step here will be to find out the equilibrium concentration of sulfur trioxide and oxygen. So first we'll have to find out the number of moles of sulfur trioxide to find out the equilibrium concentration. That will be simply the mass of sulfur trioxide over its molar mass. So the mass of sulfur trioxide at equilibrium is given as 1.17 gram, and the molar mass of sulfur trioxide is 80.067 gram per mole. And from here you can find out the number of moles as 0.015 mole. So this is the number of moles of sulfur trioxide, and then we can find out the equilibrium concentration of sulfur trioxide just by dividing this number of moles of sulfur trioxide by the volume of the solution, which is 2 liter, and this will give us a value of 0.007 molar or mole per liter. Similarly, we can find out the number of mole of oxygen just by dividing the equilibrium mass of oxygen, which is 0.105 gram, and we'll divide this by the molar mass of oxygen, which is 30 gram per mole, and this will give us the number of moles of oxygen, which is 0.003 mole. Now again, just dividing this by the volume, we can find out the equilibrium concentration of oxygen, and that will be, if we divide this number of moles by the volume, which is 2 liter, we will get the equilibrium concentration of oxygen as 0.0015 molar. Now we know the equilibrium concentration of oxygen and sulfur trioxide, and then we know that there is a relation, or the if we set up the equilibrium constant expression for this reaction, it will be the product concentrations over the reactant concentration. We have 2 sulfur trioxide, so 2 will be raised up as a power of sulfur trioxide concentration, and in the denominator we will have sulfur dioxide, and since there are 2 sulfur dioxide, so we'll have to raise the power up to 2 times the concentration of oxygen. So this is the setup, and from here we can rearrange it to find out the equilibrium concentration of sulfur dioxide. So that will be equilibrium concentration of sulfur trioxide, um, whole square over Kc times O2, and we can just put a whole square over this, whole square root over this. So thus we can get the equilibrium concentration of sulfur dioxide. So here we know the equilibrium concentration of sulfur dioxide and oxygen, which we have just calculated here, but we do not know the value of Kc, but we know the value of Kp. So from the value of Kp, we can find out the value of Kc, as we know that Kc is equal to Kp over RT whole bracket del N, where R is the universal gas constant and T is the temperature in Kelvin. So the Kp value is given as uh, 3 times 10 to the power 4, and then the value of R is 0.0821, uh, and the value of T is 700 Kelvin, and the value of del N is the number of molecules of products minus the number of molecules of reactants. So it is 2 minus 2 plus 1, that means 2 minus 3. The value of del N is 2 minus 3, that means it is minus 1. So we'll have to put minus 1 as a power, and from here we can find out the value of Kc, which is 1.72 times 10 to the power 6. So this is our value of Kc. Now if we just plug in all the values here, we can easily find out the equilibrium concentration for sulfur dioxide. So equilibrium concentration of sulfur trioxide we have calculated as 0.007 mole. So it will be 0.007 all to the power square, and the value of Kc we have calculated as 1.72 times 10 to the power 6 times the concentration of oxygen equilibrium concentration, which we calculated as 0.0015 molar. And from here we can find out, okay, so I haven't included the units here. Just make sure that you include all the units, so it will be 0.007 m, and this will be 0.0015 m. And from here we will get the equilibrium concentration of sulfur dioxide as 1.38 times 10 to the power minus 4 molar. So this is the equilibrium concentration of sulfur dioxide, and from here we can find out the mass of sulfur dioxide. And for that, first we have to find out the number of moles of sulfur dioxide, which will be molarity or equilibrium concentration times volume. So the concentration we have just calculated as 1.38 times 10 to the power minus 4 molar or mole per liter, times the volume is 2 liter, and from here we will get a value of 2.76 times 10 to the power minus 4 mole. So this is the number of mole of sulfur dioxide in equilibrium. From here we can find the mass of sulfur dioxide in equilibrium, and which is, we know that this is basically number of moles is equal to mass over molar mass. That means mass will be number of moles times the molar mass. So the number of moles of SO2 we have calculated as 2.76 times 10 to the power minus 4 mole times the molar mass of sulfur dioxide, which is 64.07 gram per mole. And from here we can get the value of mass of sulfur dioxide, which is um, 0.018 gram. So this is the mass of sulfur dioxide um, in the equilibrium for this reaction.